In today's video, we're going to take a look at systems of equations and solving them by substitution. So this is going to correspond to section 5.2 of the textbook. So just to recap, systems of equations are also called simultaneous equations, and it's when we're solving for two or more variables at the same time. And our two variables that we're solving for are x and y. And we have three methods to solve simultaneous equations. We already learned the first one graphically when we looked at the two lines and we figured out when they intersected. In today's video, we're going to take a look at this method called substitution, and it's essentially still figuring out when the two lines are going to intersect, but instead of using graphs, we're going to be using algebra. So to recap, substitution just means that if we have a is equal to 4 and it says evaluate 4a plus 3, substitution means we're going to substitute, so we're going to change our a for the value of 4. So if we were to actually evaluate this, we would then get 4, and then instead of a, we would get the value of 4 plus 3, and we would get 16 plus 3, which would give us 19. So the action of taking this value of a, which is 4, and putting that inside for something is substitution. So we're going to look at this method of substitution in today's video. So let's take a look at our first example. We're going to solve this system of equation by substitution. So these are our two equations we're going to be looking at. And I'm going to label each one as equation 1 and equation 2, just to help keep our work more organized. And here we see that our equation 1 is y is equal to 2x minus 5, and our equation 2 is 7x minus 2y is equal to 5. What we're going to do is we're going to need to substitute. And by substituting, we're going to change a variable of x or y to something else. What we want to take a note of is if we look at just this one here, equation 1, we see that we get y is equal to 2x minus 4. So it's telling us that y is that. And I see that I have a y right here. So what I can do is I can say to myself, if y is this, then this can go into that y, right? Because then they're equal to each other. So what I can do is I can now say that I'm going to substitute 1 into 2. So if I'm saying my steps out, or writing my steps out, so I'm going to sub 1 into 2. So when I substitute this equation 1 into equation 2, I now have 7x minus 2, and instead of y, I'm going to now change it for 2x minus 4, and then is equal to 5. So notice here in this red part, the 2x minus 4 is y, and the 2x minus 4 here is y. So we're substituting this inside. So now, what I need to do here is I need to solve this equation of x, and then I'll figure out what my value of x is. So I'm going to first have to look at this here. This negative 2 is being multiplied to everything inside, so we're going to have to distribute that. So we're going to get 7x take away 4x, and this is where we got to be really careful. We've got negative 2's on the outside, and that has to be multiplied to negative 4. So negative times negative is going to give me positive 8. So that's something that we're going to probably get into a lot of mistakes with. So from here, we're going to collect like terms. 7x take away 4x is 3x, plus 8 is equal to 5. So solving for x, I'm going to take away 8 to both sides. So that's going to cancel here. And I get 3x is equal to 5, take away 8, which is negative 3. So I'm going to divide both sides by 3. And I get x is equal to negative 1. So I found out what my value of x is. So now I need to figure out what y is. So in order to figure out what y is, I can take this value of x, and I can either substitute it into equation 1 or equation 2. It doesn't matter. So I'm going to choose to now take this. I'm going to sub into equation 1. So I've got y is equal to 2, and instead of x, I've got negative 1, and then I've got minus 4. So I get 2 times negative 1 is negative 2, take away 4. Negative 2 take away 4 is going to give me negative 6, so I get y is equal to negative 6. So my solution then is -1, -6. Now, what I can do, which is really great, is now that I've solved my equation using the substitution method, I can use Desmos now to double check my work and see if I put in these two equations of a line, and if I plot them in the Desmos, they should be intersecting at this point. So here we can see a screenshot where I took the two lines, so these are equation 1 and equation 2, and I just wrote them into Desmos. What's really nice about Desmos is I don't need to rearrange it. I can just take whatever I see here and put them into Desmos. And I plotted those two lines, and I see that the two lines are intersecting at -1 and -6. So Desmos is a really great way for you guys to do it algebraically, but take the time to double check your work to see if you've got the answer correct. So here are 3 questions for you to try out by solving the system by substitution, and you can check your work. So you can check your work using Desmos. So what we want to see is you're kind of looking for wherever y is equal to something, that's what you're going to substitute in. So here I've got y is equal to 2x plus 3. Here I've got y is equal to 1.5x minus 5. And here, in this one, I have x is equal to something. So whenever we see the variable equal to something, that's a good place to try substitution. So take a moment to pause the video and try out these 3 different examples. And if you get stuck, just rewind the video and watch the first example again. So let's take a look at our second example. And there's actually 2 ways to go about this question. So I'm going to go over it in one way, and I'll show you a different method to do the same question. So we're solving both of these 2 equations at the same time. Now, we're going to use substitution, and what we're going to notice here is that I see that I've got 2x is equal to something, and I also have a 2x here. So because I see 2x twice, I can now see that I can take this, which is 2x, and I can put that in and replace it for 2x here. So again, I'm going to name my equations as equation 1 and equation 2. And what I'm doing is I'm subbing equation 2, so sub equation 2, into 1. So when I do that, instead of 2x, I'm going to have my y plus 5, and then I have my plus 3y is equal to -3. So do we see that this y plus 5, this y plus 5 is going into here? So now I'm going to solve for y. So I can collect like terms, so y plus 3y is going to give me 4y, plus 5 is equal to -3. So solving for y, I'm going to subtract 5 to both sides, and I get 4y is equal to -8. I'm going to divide both sides by 4, and that's going to cancel, so I get y is equal to -8 divided by 4, which is -2. So I have one of the numbers I need. So now I can take this y is equal to -2, and I can either substitute it back into equation 1 or choose to substitute it into equation 2. So I'm going to just bring this up here because I'm running out of space, and I'm going to sub into 1. And it doesn't matter. So 2x plus 3, and instead of y, I've got -2, is equal to -3. So 2x, take away 6, because 3 times -2 is -6, is equal to -3. So I'm going to add 6 to both sides, and I get 2x is equal to 3. And then I get to divide both sides by 2, so I get that x is equal to 3 over 2, or x is equal to 1.5. So I've got 2 numbers here. My solution then is now 1.5 and -2. And for those of you who like decimals, 1.5 and -2. So this is my solution to this problem here. Now this isn't the only way to go about this problem algebraically, so we're going to look at this example again, but look at it in a different way, and you can decide which method works better for you. So we're going to do the same problem, but we're going to approach it in a different way. So before I took all of this y plus 5 because it was equal to 2x, and I substituted it inside for this 2x here. And that's one strategy, but we're going to approach this in a different way. So what we're going to do now is I'm still going to label it numbers 1 and 2, so equation 1 and equation 2. Now, I'm going to make it so that it's also nice if we have x is equal to something or y is equal to something. So I'm going to look at this equation here, equation 2, because I see that I've got y by itself. So what I can do is I can solve this for y, just like we did when we were graphing the lines and you wanted it in the y is equal to mx plus b form. So if I have the equation 2x is equal to y plus 5, and I want y alone, I'm going to take away 5 to both sides, and I get 2x minus 5 is equal to y. So now I have this equation here instead. So instead of being this equation 1 and this equation 2, I'm now going to have that this one is my equation 2, and I don't need this equation here anymore. So now that I have it like in this strategy, I can see that I've got y is equal to something, so I can substitute this y is equal to something inside for y. So this equation now, equation 2, is still the same as this one. All we did was rearrange it. So again, we're going to now take we're going to sub equation 2 into 1. And I'm going to get, here I've got 2x plus 3, and instead of y, I've got my substitution of 2x minus 5, and then is equal to negative 3. So just to give yourselves a little bit better visual, here is my y, 2x minus 5, and I'm substituting it for this y in here. So I'm putting all of this inside for this y. So let's go about this algebraically now. We're going to expand our bracket. So we have, in this case, we've got 2x plus 3 times 2 is 6x, and then positive 3 is on the outside multiplied to negative 5, so negative 15 is equal to negative 3. So 2x plus 6x is 8x. Take away 15 equal to negative 3. We're going to add 15 to both sides, and we get that 8x is equal to 12, and we're dividing both sides by 8. And we get x is equal to 12 over 8. I can simplify that by dividing both the top and the bottom by 4. So I get 3 over 2. So x is equal to 1.5 for you decimal lovers. So x is equal to 1.5. Or you could say that x is equal to 1 and 1/2 like this. 1.5 or 1.5, sorry. So what we're going to do now is we're going to take this value that we get for x and we're going to substitute it into another equation. So we could sub it into 1 or 2, it doesn't matter. Let's sub this into 2. So sub into 2. So we get now our equation 2. I can use the original one that I had here before I rearranged, that's fine. So I've got 2. And instead of x, I've got 1.5, and that's equal to y plus 5. 2 times 1.5 is going to give me 3, is equal to y plus 5. And to solve for y, I'm going to take away 5 to both sides, and I get that negative 2 is equal to y. So my second solution is y is equal to negative 2. And then if I write this out as a coordinate, so my final answer is going to be this coordinate of 1.5 and negative 2. And that's going to be my final answer. And again, we can use Desmos and see if when we graph equation 1 here and this original equation 2, do they actually intersect at this point? So here are your last 3 try questions for this video. Number 4 is really nice because it says y is equal to this and y is equal to this. If they're both equal to y, they're equal to each other. So when you're setting up yourself up for this problem, we can say that negative 3x plus 2 is equal to 2. So that's for number 4. If we take a look at this one, 4y is equal to x, and here we got x plus 4y. So we can kind of notice that this is an x here, and we got an x here. And we also have a 4y here and a 4y here. So we can see what we can maybe substitute inside. Number 6 is a little tricky because you've got 2x plus 2y is equal to 1, and you've got negative x plus 2y is equal to negative 3. We want to look for what's in common, so they both have 2y's. So I've got a 2y here, and it's positive 2y, and a positive 2y here. So what we probably want is our equation to say 2y is equal to something so we can substitute. So we're going to have to do a little bit of rearranging because neither of these say 2y equal to something because they've got these x's or 2x's in the way. So try out these 3 problems. So there's 6 in total. And try them out. Remember, you can use Desmos to double check your work and see if you are correct. But you can't be using Desmos to just give you the answer because we do want to be able to do these algebraically. So good luck with these 6 questions in total, and I'll see you guys in class. Bye.